one actually has a problem on the front page and then also a problem on the back page. So we're going to start with, I know, exciting. We are going to be asked to find all three of these, sine, cosine, and tangent. So I know I just mentioned this, but for SOHCAHTOA, if you remember this should probably be enough for you to get it correct. So the S in SOHCAHTOA stands for sine, right? And this stands for the opposite side. And then the H always stands for the hypotenuse. The hypotenuse. You guys remember how to know which one is the hypotenuse? It's okay, that's why we're doing it. It's always the side length across from the 90-degree angle. Okay, I'll repeat that. The hypotenuse is always the side length across from 90-degree angle. Correct. And it will always be the longest side. All right, so if you're finding side lengths and you find that the hypotenuse is not the longest, then you've done something wrong. Okay? For ka, that's cosine, C-O-S, cosine. A stands for the adjacent side. Adjacent, so that's next to, right? And then H, again, is the hypotenuse. So the cosine of an angle is equal to the ratio of the adjacent side over the hypotenuse. We're going to practice a ton, I promise. And the last one, toa, the T stands for tangent. The tangent of an angle is equal to the ratio of the opposite side over the adjacent side. All right, so make sure you have your calculator handy. We're going to need it for these questions. All right, so let's start with this first triangle, triangle IHG, and it's asking us to find the sine, cosine, and tangent of angle G, this only one right here. All right, now, the first thing that I'm looking at here, all right, is when I try to figure out how to find these ratios, all right, I notice that they're giving me 2 out of 3 of the side lengths. So I'm going to label them in terms of the relation with angle G. So if you look here, if I go across the triangle, you see this side that I don't have? That is the opposite side. All right, so that is the opposite side. Now, again, looking from the perspective of angle G, do you see this side length that's 39? What does it say unit? But 39 units. This is the adjacent side. All right, and then I told you guys, what is the name for the side that is across from the 90-degree angle? Hypotenuse. Very good, Mira. Hypotenuse. Okay? Now, the hypotenuse will never change. But what if I change my perspective to say instead of from angle G, I said from angle I? Then when I look across, this 39 would actually become the opposite side if you're looking from angle I. So just want to make sure you're clear on that. These will not always be the same, but the hypotenuse will never change. Hypotenuse is always the same. So like if I was asked to do like the sine of angle I would care about the opposite side. And this is, see how I wrote adjacent here? Because from angle G, this is adjacent. But from angle I, that 39 would be opposite.
So the opposite is the directly across from the angle you're doing?
Correct, yes. And then the adjacent one should be like next to. So this, where I wrote opposite, is actually the adjacent side to angle I. So just be careful when you're doing opposite and adjacent. Okay? Okay. So let's see which ones I know. So let's do the sine of angle G. All right. Do I know the opposite side of angle G? Do I know the opposite side of angle G? So my opposite of angle G is actually this side length, and I do not, right? So this is going to be question mark over, you're good, over the hypotenuse. And what is the hypotenuse? We do know that. What is the hypotenuse? 89. Nice. Okay. I'm going to set up another one. So I have the cosine of G. Okay. Cosine is the adjacent side over the tangent. Do I have the adjacent side when I look at angle G? I do, which is 39 over the hypotenuse, which is 89. Okay, so that one I can actually say I'm done, and I can try to reduce that. I don't think you can actually reduce that. Those are both prime numbers. Nope, they're not prime numbers. Maybe I can't reduce it. We'll see. And then tangent. is opposite over adjacent. And do I have the opposite side? I do not yet. So I have question mark over what is the adjacent side? 39, okay? So at this point, are you guys okay with the trig? So that was using the SOHCAHTOA, the trig ratios. Do you see how I have a few question marks? All right, I need to figure out what that question mark is. Do you remember how we can find a missing side if you know 2 out of 3 of them and it's a right triangle? Your favorite mathematician. What is it? Oh, no. It's a good F word, but no, it's not an F word.
Function?
No, it's not an F word. This mathematician's name starts with a P. Peter? No, that's my brother's name, not Peter. A Y? Oh, what up, Pajama? The Pythagorean theorem. Your favorite mathematician is Pythagoras. Oh my gosh, I know you guys missed it. Do you remember this formula? A squared plus B squared equals C squared. All right, remember which one always has to go with the C? Which one always has to go here? So we say the hypotenuse. Very good. Mary's like, just say the hypotenuse. It'll be right. Okay, so I'm going to put 39 here. Do I know the opposite side? I do not. Equals 89 squared. All right, let's get out our calculators. So we have 89 squared, which is 7921. 39 squared, which I got is 1521. So I'm going to move that 1521 over with subtraction. And I got 6,400. How do I find that letter B? The square root, nice, gentlemen, square root of 6,400 is 80. So this side length B, I'm going to replace on my original diagram where it says opposite. So I'm going to put here is 80.
Oh, so I was right.
I don't know. Were you?
I got
Samantha. So I moved this 1521 over here with subtraction. So I did 7921 minus 1521, which gave me 6400. So do you see how it says B squared? To go to just B, Ijoma told me to take the square root. So the square root of 6400 is 80. Now, a nice check here, Emmanuel, a nice check here is to make sure that what you found is not larger than the hypotenuse. Which one is the hypotenuse? 89. Is 80 bigger than that? No, so that's good. So if you find something that's larger than the hypotenuse, that's not okay, right? The hypotenuse is always the longest side length. Okay? So now do you see my question marks in my ratios for sine and tangent? I'm going to replace those question marks with 80 because that's that missing side. So I'm going to write this is 80 over 89. And this one is 80 over 39. I'm going to, bless you, I'm going to use my calculator to see if I can reduce any of those. This one is done. I don't think so either, but I just want to confirm. This one is done as well. And the last one is done as well. All right. So on IXL, you're going to have to type these 3 in. You see I put the little blanks here? You'll have to type these in those spots. Are there any questions? As fractions, yes. Are there any questions on number 1? I know that was a lot. We're going to do number 2 on the back side, yeah. Yes, Mary.
I kind of like zoned out whenever you were doing the. Mister, what do you put in those squares?
Hold on, let me get Miriam's question first. And then I'll go to you.
When you were doing the.
Pythagorean theorem? Yes.
So you didn't plug that in so it has a name on it.
Yeah, so well, first, are you good on why I put like this stuff here?
Yeah.
Yeah, because C should always be the hypotenuse.
Yeah.
And then, so I did 39 squared in my calculator. Got that. 89 squared is that.
Oh, you did separate. Okay.
Yeah, and then I moved this over with subtraction.
All right.
So that's how I got this. And then I took the square root of this to get 80.
Okay.
and that is my missing side length. So I replaced that where my question marks were for my adjacent side.
Okay, and they're all like over the hypotenuse except for
tan. Very good, because you're always going back to SOHCAHTOA. That yes, sine. I can write it like this if you'd like. Sine is equal to the opposite over the hypotenuse. Cosine equals adjacent over the hypotenuse, and then tangent is the only one you're right which is opposite over adjacent. Man, I can't write today. I'm sorry. Please, yeah, take your time to write it. I can't write letter D's yet. There we go. Okay, so there's Gladys. Question?
What do you put in those squares?
Oh, the answer. So like this one here, I can't fit it because the squares are so small. But this one is the sine. This one is.
You can't make it smaller.
I didn't. I typed in my calculator all those fractions with the N over D button, and none of them could reduce. So I just leave it like that. If I can reduce, though, I do reduce.
So I can finish writing
It does say no, because if you look at the answers here, it says simplify your answers and write them as fractions, improper fractions, or whole numbers. So no, it doesn't say decimals. I'm sorry. Okay, question? Oh, yeah, sorry. There you go. Are you trying one right now, Minerva? All right, I'm going to do number 2. So when you're ready, flip over to number 2. This one is one of the hard ones. Like I told you guys, I like to do more of the ones that are like into the 70s and 80s where you can get to the challenge zone. I know yesterday was a lot of fun. I hope you enjoyed it. But this right here is where you're finding all 3. It's not going to happen until later on in the link. The first parts of the link will just be like find 1. Oh, yeah.
Are we taking next week?
Oh, man. Good thing we're doing this. Okay, number 2.
On Thursday. Well, y'all take it the week after that.
All right, here's number 2. Now, this one is a little bit simpler, just for the pure reason you're only finding one of them, right? So if you write down what Miriam just finished writing, the tangent of W equals the opposite side over the adjacent side. I did it again. There we go. All right, so I'm going to angle W. And where am I looking for my opposite side from angle W?
VU.
Very good, VU, right? Do I know that, though? I do not. So that's a question mark that I'll be solving for with the Pythagorean theorem, okay? Where is the adjacent side? It's going to be tricky here. Where's the adjacent side? That's what most people will say. But actually, 97 is across from the right angle. So 97 is the hypotenuse, which I will not be using in my ratio. I will be using it in my Pythagorean theorem, but not in my ratio. So the adjacent side is actually 65. Okay, so let's use the Pythagorean theorem. A squared plus B squared equals C squared. 65 squared plus B squared equals 97 squared. I'm going to go to my calculator to get those numbers. $65 squared is 4225. Correct. 97 squared is 9409. Samantha, I'm going to move this 4225 over to the other side with subtraction. So I'm going to do 9409 minus 4225 to get 5184. I know I'm going fast. The square root of that is 72. So I'm going to put that where it says the opposite side. So now I'm going to write my ratio. The opposite side is 72. The adjacent side, we said, is 65. And if you go to the calculator, let's see if we can reduce that. You cannot. This is the answer. I'm so proud of you.